To and respected listener, a very good evening and welcome all of you to today's lecture. Dear students of B.Sc Part 2, I will deliver today a very special topic, that is I will mention on the blackboards Le Chatelier principles, which is selected from B.Sc Part 2, Paper 3 Physical Chemistry, selected from that is of Unit 3, titled as that is of Chemical Equilibrium. I bring to draw your kind immediate notice, dear students of B.Sc Part 2, once again. Before proceeding of today's lecture, the Le Chatelier principle, once again I repeat, about the fundamental, conceptual, scientific rules, definitions of equilibrium constant Kc and Kp, we have delivered in our previous lecture. May I have your attention please, dear students of B.Sc Part 2, in which equilibrium constant Kc is equals to or is the constant when the concentration of the multiplication of active mass of the product when is divided by the concentration of active mass and its multiplication of the reactant to give the value of equilibrium constant, and is symbolized by that is of Kc. Dear students of B.Sc Part 2, once again, equilibrium constant Kc is applicable for any chemical reversible reaction in which reactant and product are present in that is of liquid or that is of solid phase. Suppose in chemical reversible reaction, suppose reactants and products are present in gaseous phase in such a position, equilibrium constant Kc is replaced by that is of newly constant, also known as that is of equilibrium constant for gases Kp, and symbolized by that is of Kp. Dear students, I repeat your basic conceptual you have studied in that is of B.Sc Part 1. According to the kinetic theory of the gases, the concentration of all the gases one can express in terms of partial pressure or pressure. Partial pressure, the pressure which is measured by individual gas, the pressure dropped, the force dropped on a particular force of and its area or internal space here. We have also derived the essential quantitative relationship between Kp and Kc. I mean to say Kp is equals to Kc RT to the power del n, where del n that is the sum of and difference of the number of products and that is the number of moles of that is of reactants here. In various cases, by considering in reversible chemical reactions, we have also studied about del n is equals to 0, del n is equals to positive, and del n is equals to negative. And after discussing the overall and that is of a whole previous discussion, now let us come today on our that is of fundamental lectures based on Le Chatelier principle. According to Le Chatelier, which is the famous scientist, on changing in any chemical reversible reaction, the equilibrium or equilibrium shifted in that particular direction to remove by doing the change, and it should be the counterbalanced by means of temperature, pressure, concentration, catalyst, and addition of that is of inert gases also. This effect or this law is known as that is of Le Chatelier principle. Let us try to understand the first factor, try to understand about on the behalf of that is of concentration here. In order to explain the Le Chatelier principle in chemical reversible reaction, I have mentioned on the blackboard here, that is of 1 mole of N2 reacts 1 mole of H2 to produce twice mole of NH3. In such reversible reactions, the upper reaction shows forward direction sign and lower reactions show backward direction here. Here in the case of N2, 1 mole of N2 reacts thrice mole of H2 to produce twice mole of NH3. On increasing the concentration of 1 mole of N2 and thrice mole of H2, dear students, for the counterbalance of the equilibrium or changing equilibrium shifted from to that is of left hand direction to that is of right hand directions. I mean to say equilibrium shifted from shifted to that is the forward direction. And after the complete formation of here in this reaction, twice NH3 when it's produced, when it's formed in excess quantity, again it start to decompose back to form once again 1 mole of N2, thrice mole of H2. In such a position one can say that twice mole of NH3, or I mean to say equilibrium is shifted in that is of backward directions. Now let us try to understand next factor, try to understand that is of that is of effect of pressure. Dear students, B.Sc Part 2 effect of pressure on chemical reactions contribute to play a very, very special, amazing role for the formation either of the reactant and that is the product here. But let us try to understand its first of all its preliminary concept and theory of Le Chatelier principle using that is of here pressure. According to Le Chatelier principle, by means of pressure in any that is of chemical reactions, on applying, on changing or on increasing the value of pressure, equilibrium shifted to that direction to possess the low number of moles or molecules in the form of products here. In order to explain, I mean to say when del n is equals to negative, what will be the position? In such a position, equilibrium or equilibrium is shifted from that is of left hand direction to that is of right hand direction. I mean to say that is of forward directions. Here 1 mole of N2 plus thrice mole of H2 to produce twice mole of NH3. The value of del n one can calculate, that is of -2 here. I mean to say here that is of del n passes that is of negative value. Right hand direction you know here, that is of in this one direction that is of total number of moles present H2 less than that is of 1 mole of N2 and that is of thrice mole of here that is of H2 here. So obviously there is no doubt here on increasing the pressure on such reversible system, equilibrium is shifted from left hand to right hand direction. I mean to produce that is of twice mole of NH3 to possess that is of to increase the concentration of NH3 here. I mean to say here in order to obtain the excess quantity of that is of ammonia, we have to increase the pressure. In reciprocal that is of case second here. Let us consider here next one when del n is equals to positive here. In such a position, equilibrium is shifted from that is of right hand to that is of left hand direction. I mean to say equilibrium is shifted in that is of backward direction here, because here del n is equals to 1 mole of PCl3 next 1 mole of Cl2 twice is now less by that is of 1 that is of PCl5. I mean to say that is of equilibrium shifted in that is of backward directions here. So I mean to say, dear students, in such a reversible chemical reaction on increasing the value of pressure, equilibrium shifted in that direction passes the low number of molecules here. Let us try third one and last one case of that is of pressure when del n is equals to 0. Very, very special. There are so many reactions in the field of inorganic and organic where number of molecules and number of reactants and products are the same. Such example I have mentioned on the blackboard here. 1 mole of N2 reacts 1 mole of O2 that is O2 produce twice mole of NO. Dear students, here del n is equals to 2 minus 1 plus 1 that is equals to 0. In such a position, dear students of B.Sc Part 2, the on changing, on increasing the value of pressure, equilibrium or equilibrium state is that is of unchanged, remains the constant. I means that is of then there is no that is of effect on that is of equilibrium. Equilibrium will be as such will be the remains the constant. Tomorrow we will discuss, we will deliver here next factor by means of concentration, catalyst, and that is of addition of inert gas. And what let us try to observe what will be the position of shifting of equilibrium state and equilibrium constant tomorrow. Thank you very much.